Okay. An ellipse. Here's the general form, the shape of an ellipse centered at the origin. And if we want to replace x by x minus h and y by y minus k, then it's centered at hk. Okay? Okay. Well, what I do is I say, okay, here's the point A0. Here's the point negative A0. Okay? Then here's the point negative B0 and the point B0. If you want to sketch the ellipse, I just sketch this rectangle and then
trace.
Sketch the ellipse. Very simple. And the rationale, well, I mean, you have to prove these things, but you know that if y equals 0, that x is going to equal either a or negative a. Because x squared or a squared is going to equal 1, x squared is going to equal a squared, so x is plus or minus a. Well, that's those 2 points. Okay? And then let x equal 0. You see you got these points. Okay? And then you get the definition of the ellipse, and you got this focus. Negative C0, C0. I don't think I necessarily located that very well. And the sum of these distances is always the same. So what's the sum of these distances? Well, the sum of these distances is distance from here to A, which is A minus C. Okay? And from here to negative A, and that's A plus C. Okay? So it's 2A. Sum of these distances is 2A. Right? Okay? And of course, if A is greater than 0, the focus lies along the x-axis. If B is greater than 0, the focus lies along the y-axis.
Yes. And
the sum of the distances could be 2B.
Yes.
Or not 2B in the case that it's A.
Yeah.
2B or not 2B. Okay. Now, you're pretty literate, so I can do these things.
Yeah.
Okay, now, there's an ellipse, right?
Yes.
Okay. Hyperbola. I'm writing faster than I'm thinking, because I'm not thinking. So anything I do is faster than my thinking. Okay.
Oh.
Got it?
Yes.
Okay. Well, you can reason this out pretty easily too. Okay? There are your asymptotes. Your vertices are either here and here or here and here. In this case, they've got to be here and here.
Yeah.
Okay? Because if y equals 0, x equals plus or minus a. If you thought they were here and here, you would have x equal to 0, and you'd have a negative equal to 1.
Yeah.
So, and of course, if you have this, well then, it's y equals plus or minus b when x equals 0, right?
Yes.
So you have two possible hyperbolas. Make sure they don't start curving back in. It's real easy to do that and mislead yourself.
Indeed.
I do it, but I don't mislead myself because I know better. And
Yeah.
so do you. Still, you might want to think about drawing something. Say I did it again. Anyhow, you get the idea, right? So there is what you need to know about the shape of hyperbola. And you got to focus foci.
Which is C.
And you can also do this in terms of focus and directrix and all that stuff. Okay? Yeah, which we're not going to go into right now because it's not particularly relevant to where we're going with it. Actually, I'm not doing that. Okay. Well, you got standard form for hyperbola. Let's just say we've got, that's a hyperbola parabola. Okay, I don't know if this is the right word. You would have something like this, right?
Yes.
Okay. And that's going to be a parabola, vertex at the origin, etc. Right? So I'm not going to say too much about that because that's really straightforward. It's just a transformation of a y equals x squared function. It's got a directrix and a focus that are related to this number. Not if A and B have different signs.
Okay.
I didn't make any assumption about the sign. Or, okay. Make sure these don't go vertical either.
Yeah.
I didn't need the norm sign there. Okay?
Okay.
Just cover the possibility.
Okay.
Okay. So looking at a quadrant surface, the first thing we kind of look at is intersections of the surface with the coordinate planes. Let x equals 0, see what you got. Let y equals 0, see what you got. Let z equals 0, see what you got. Then you pick one axis pretty much and ask yourself, okay, now if I take planes above and below the xy plane, how do the shapes change?
Okay.
As we did with the first example. You got a circle here, and they get bigger and bigger, as you maybe think they're linear, but they could be parabolas, so we go up like this. Paraboloid of revolution, or an ellipsoid. You know, just extend the circle out into an ellipse, one way or the other, and you have ellipses building up. They're all geometrically similar in that case.
Okay.
Because all you're doing is changing, let's say, z. So whatever the coefficients are here, every time you increase the magnitude of z, you increase this number. So if you have an ellipsoid here, it just gets bigger.
Yes.
Okay?
Okay.
Okay, well, that's the first thing you want to understand about quadric surfaces, and I'm going to have to end class on time, just to complete preparations and so forth.
Okay.